So this is a very, very simple setup. At the left, you see what we just did in the last model, a pain-intercept 1, 1, 1, 1, 1, and a pain slope 0, 1, 2, 3, 4, with homogeneous residual variance over time. And at the right is the mirror image for mood. A mood intercept 1, 1, 1, 1, 1, and a mood slope 0, 1, 2, 3, 4, with a second homogeneous residual variance over time. The big difference is that there are now 6 possible correlations among these 4 intercept and slope factors, and we're estimating all 6. So here is the Lavaan version of that model. As you can see, I and L are the intercept and linear slope of pain, while I2 and L2 are the corresponding intercept and linear slope of negative mood. And lines 13 through 17 give all the pain residuals homogeneous variance, and lines 18 through 22 do the same for negative mood. And lines 3 through 9 let all 4 latent variables, both intercepts and both slopes, fully correlate, as you saw in that picture 2 slides back. Again, the loadings aren't interesting because they're just numbers we fixed. The fixed intercept of pain is 49.2 with a linear slope of 2.4. And mood looks very similar, fixed intercept of 49.5 with a fixed linear slope of 2.4. Now, down below, we see how the intercepts and slopes are associated, and most of them actually aren't, but we see 2 interesting associations. The pain slope is related to the mood slope, and the pain intercept is related to the mood intercept. And for those of us who are visual learners, I just superimposed those 2 significant associations on this figure. A few points to note. First, by implication, it means that people who have a lower average level of pain also have a lower average level of negative mood, and also people who show more increase in pain over time also show more increase in negative mood over time. I left these associations and covariance or unstandardized metric, but we know from the last slide that they're significant. The one downside of what I've done here is that we can't tell if the intercept association is stronger than the slope association, for which we'd need to express them as correlations. Here we ran into a Lavaan issue, a non-positive definite warning, meaning the standardized value of the bottom covariance estimated at slightly above 1, an impossible value. Because we didn't predict anything, we only correlated, the random variances and residual variances are essentially unchanged from our last model. If we want to know how much variance, for example, mood predicts in pain, we need to rerun this as a regression, and that is coming. The fit is not too shabby, if not perfect. While chi-square is significant and more than twice the degrees of freedom, both fit statistics are above 9.9, and while the RMSEA is large and significant, the SRMR looks good. Now, next, I want to stick with this same model, except I want to recast it as a regression rather than correlations.